So get started.
Yes. Okay, it's time to start the session. From TensorFlow to ML Kit, power your Android application with machine learning by Qian Jin.
Konnichiwa, good morning. I'm Qian Jin, Jin Qian. So I'm originally from Hangzhou, Chinese, currently living in Paris. On a daily basis, I'm an Android developer, and I'm also a GD for IoT. So this is my handle. Don't hesitate to ping me if you have any questions. So as a mobile developer, I think you are all familiar with how to use different APIs to do a lot of complicated operation. Maybe some of you have already used the machine learning type of APIs, for example, to recognize your image, to recognize some facial expressions. So cloud intelligence has been there for a long time, and we're all very familiar about it. And today I want to show you mostly about how the emerging on-device type of intelligence is impacting the mobile development. As you all know, Moore's law has been successfully predicting the development of hardware for the last 50 years, and it keeps pushing. And we all know there's already 7 nanometers chips available on the market. For example, the Apple's A12, which is released last year, and a lot of hardware company has started to produce special chips which are optimized for machine learning type of operation. For example, there's Qualcomm. They have a special digital signal processor chips which runs TensorFlow about 10 to 15 times faster than the normal CPU. A lot of companies such as Google has started to work also on solutions such as IoT Edge and Edge TPU. So TPU means Tensor Processing Unit. It's actually a special chip which is designed to run the machine learning operations. And they're emphasizing on this kind of solution to push the machine learning to the edge devices, which means you can do a real-time operations thanks to the data you collect with the edge device, and the data stays on the edge device and provide more privacy and reliabilities. Today, I handpicked some very important events on the timelines, which follows about the different phase of machine learning for mobile development. So I'm pick up several events and tells you and share with you my experience of how I experiment and play with the technologies of machine learning for Android. So actually, at the end of 2016, TensorFlow team released an Android demo. So at the time, we were very excited with my coworkers. We were saying, hey, let's try it out and see what it gives. So at the time, the demo has to be compiled with Bazel. I don't know if you all know Bazel. So Bazel is a build system made by Google. So we're very, very excited. And the night we spent maybe 20 minutes to compile the demo. And the demo actually instantly recognized the beer bottle and the joysticks hanging around in our office. I was very excited. I was like, hey, I can do machine learning with everything, and it seems so cool. I can probably recognize other objects such as chairs, such as microphones and computers. Let's do something cool with it. And I was saying, hey, I'm a foreigner in France, and at the beginning when I arrived, I always have troubles naming daily objects such as fruits, vegetables, and the most simple objects. Let's maybe try to build some application that it kind of be your eyes and tells you what the object's name is. So I was thinking about the application should call Magritte. So it's René Magritte. So it's a Belgian artist who is very well known for his abstraction works. So the app should just simply tells you what the object is and pronounce it. And it helps you learn foreign languages. You can imagine as many possibilities as possible. After I pitched the idea to my coworkers, which is a data scientist, and he was like, are you sure we can do it? We can do it about it, but you cannot just start it with the demo you had. Then that's a moment I realized there's no machine learning model for everything. You actually have to prepare your own model if you want to recognize specific objects. At the end of 2016, I was a completely newbie as a machine learning in terms of machine learning. So I was thinking I should start by just understanding how things works. So how does neural networks and all the buzzword and popular words means? So as you can see, the artificial neuron is actually just like the neurons inside our human body, and they have synapses. And the synapses all carries a weight. So consider the weight a strength of how inputs can influence the outputs. Every time there's an input, the synapses is going to take the input value and multiple with the weight, then you will get output. So every neuron will take all the inputs and apply an activation function, then obtain an output. From the point of view of a linear algebra, it's actually the weight is actually a vector of values. So those values not only they have the numeric value, they also have a direction. So every time an input is multiplied by the weight, it gets an output with a direction. So every time different input will determine a certain output. That's how the whole the whole value thing works. And here is a layer. It's a layer of 3 neurons. And when we talk about neural networks, that's how it works. You have different layers of neurons. But what's actually the operations we do with a neural network? So mostly we're doing inferences. Inferences means recognizing an image. So we take an input, like a bitmap, and we give all the information, feed the information to the neural network, and the neural network will tell you what's the object is actually. So if we're using a trained neural network, the neural network will successfully predict it's an apple. But how do we actually have a trained neural network which works in our way? So actually, we train our neural network with a back propagation way. What does that mean? So I just I normally just initialize a neural network with random weights, which means the weights are not very correct. At this time, if I'm giving it an image, it will probably not be able to predict it well. It would say, oh, it's only like 34% apples. So at this time, I will tell the neural network, hey, there's a prediction error. It's actually an apple with a lot of with certainty. So at this time, I will go back and update all the weights of the synapses and all the way to it. Sorry. So my neural network can store the new values. And next time, when my apples goes through, or my banana goes through the neural network, it will predict it properly. So that's how we train a neural network from something which is initially wrong and to something which initially, something finally very efficient. And we talk a lot about the deep convolution neural network for several years. So that means we have a lot of layers. So instead of the simple 3-layer neural network you just saw, there are actually thousands of layers. There are layers specified, specialized in recognition edges. There are layers specified, specialized in recognition shapes and other higher features. And there's the end layer, which is a classifier, which helps us to know what's the object exactly. If I'm giving a photo of ships, so that's how it happens. This is a photo from Stanford's computer science class. But actually, in real life, to have a very efficient machine learning model is a very hard thing. We have to use powerful machines such as this one, this kind of GPU to train and with millions of images. And as an individual, we normally don't have that kind of resources. So what we do in most of the time, and as a mobile developer who want to try out machine learning stuff, we can just do transfer learning. So what is actually transfer learning? Transfer learning means we're keeping all the weights as it is. For example, there's a lot of famous models such as Inception V1 all the way to Inception V4. And those models are built by Google and trained on millions of images. And they're actually perfectly ready to recognize basic shapes and higher features. So what we needed to do is only to update the last layer, so which is the layer do the classification. Once we do that, the model is ready to use to recognize the objects we want. So at the time, I think I'm ready to start building my Magritte app. I started to install Python environment, just as everybody else. Python can get really messy, so I recommend you to at least use some of the virtual environment package manager, something like that. And then, as all the data scientists already know, the very hard part is to collect data and clean up your data set so it can be really proper to use. So I started gathering data. There's a very famous website called ImageNet. So ImageNet provides a lot of already well-labeled images. Then you can use it directly. I think I crawled around 200 to 300 photos per category. So I have like apples, bananas, grapes, and kiwis. In terms of training a model, it's very simple. There's a code lab called TensorFlow for Poets. That's the best place to start to use TensorFlow. So actually, the scripts for retraining only takes like several lines, and different parameters actually has meanings. And you can find everything well documented on their websites. There's another tool called TensorFlow Board. So TensorFlow Board is a visualization tool which helps you to visualize the training process. For example, as you can see here, something actually happened. The orange lines represent the cross entropy of my training sets. Cross entropy is a loss function which measures the performance of the classification model. Actually, on that you can see, and it actually when it's smaller, it's better. So it actually works perfect on my training model, but not on my validation model, validation photos. So validation photos actually the test set, which to test if my model works well. As you can see here is a situation called overfitting, which means it works only really well on training set instead of the validation set. So I adjust a little bit my parameters. At the end, I have a really well cross entropy. As you can see, they're well synchronized now. So that's a good sign. So that's a very simple thing to use once you understand it, but don't get afraid. Don't just get afraid of seeing cross entropy or this kind of word. It's actually okay. Once your transfer learning finished, you will obtain the retrained model, which is a portable file at the beginning. So it's in 2016 and 2017 with a label file. And you can just use them inside your models, inside your Android applications. But at the time, my Android application gets really, really huge. So it's 80 megabits. I was like, why it's so heavy? Actually, because the model, it restored everything, all the weights as 32 bits floats. So they get really heavy. And actually, we don't need that kind of precision. So what you can do as one of the optimization is to do the quantization. So once you do the quantization, you are gaining around 75% of the model size. So I did my first version here, beginning of the 2017.
Let's learn to say the name of some fruits.
As you can see, it takes 3 to 4 seconds to recognize. So it's like 2 years ago already.
Apple.
It's the very first version. And as you can see, it's running on offline, airplane mode completely.
Banana.
And the precision can get really high. It's around 95 to 96%.
Kiwi.
So the Kiwi works well when it's open. So because all the trainings data Kiwi is open. And just several months later, Google released the MobileNet. MobileNet is a machine learning model which is optimized for the mobile and embedded devices. They're giving some really beautiful diagram to say, hey, the model works really well, you should try it out. And they actually reduced the size by drastically. I was like, hey, let's give it a try. Actually, it's very simple to try the MobileNet models. You just have to change the architecture you are using inside your training Python scripts. That's just one line to use the model, actually. And I did my second try at the end of 2017 with the same devices, as you can see. And let's see how it works. So it's inside a supermarket in France. It's significantly faster, just like in 6 months. So as you can see, the machine learning on mobile devices is the same device. And what I do was just using the MobileNet. Everything else, the code is the same. I was like totally get mind blown. I was like, oh, that's so cool. And we can actually being production ready for a lot of kind of mobile apps. And I did some small benchmarks with the model. So this is a mobile Inception V3, so the model used in the first version you saw, and already optimized and quantized. So that's the CPU and memory usage. And when I use the MobileNet model, which 1.0 means I use all the weights. So all the weights has been stored, means really high precision. You can see the memory use and CPU use are both dropped a lot. And if you use less weights, so means the model gets even smaller. But like you might sacrifice some of the precision, but it's still very high precision. As you can see, it drops really a lot in terms of memory and CPU usage. Under the hood, it's very simple actually. What happens inside the mobile apps is you capture the image from the camera flow. Then you do the central crop. Then what you do is resize the image so it's the same size as your training data. Then you can do the rest of the operation. And under the hood, it's actually like this. Oh, sorry, goes too fast. And TensorFlow is taking care of everything. What you have to do is just to feed the framework the right size of the bitmap, and the rest will be okay. And you get a confidence and the result of the classification at the end. What I do with the first version was I was hosting my own model on a server. With a REST service, because at the time there's no ML Kit yet, and so I have to do everything on my own. If I want to update the model, I have to create a sort of REST service APIs to tell my application, hey, new version of model available, you can download now. Then at the Google I/O last year, I think you all heard the release of ML Kit. So ML Kit is actually a part of Firebase now. ML Kit is in the house. ML Kit is mostly, you can find ML Kit in this horizon. So there is a part of the Google products which allows you to use your own training data to train your own models. There is a part of Google's products are ready to use, all those APIs. And Firebase ML Kit is kind of between the both, because they have a part which is vision APIs, and then another part is custom models. So the vision API actually regroups the mobile vision API and the Google Cloud Vision API. And the custom model actually is a custom wrapper of the TensorFlow Lite, which is optimized version for mobiles, and with Android, the neural network APIs. And the good news is, like maybe 2 or 3 days ago, they released a new feature, which is the natural language recognition. So you can actually identify the language with ML Kit now. As for the Vision API, I will just give you a glimpse of what they have. You might already know the Translate API, facial recognition API. For example, I tried it with my coworkers and adding some accessory on our face. They have face contour detections now. There's a barcode, and there's object recognition. So these are already ready in the ML Kit. What I'm most interested in is the custom models API. So the custom models actually hosts your TensorFlow Lite model, and it does the on-device ML inference just as TensorFlow and TensorFlow Lite. It's actually fall back to the models on device if the downloading is not success, and it can do the over-air model updates. What you have to do is train your TensorFlow model first, just as I showed it before. Then you convert it to the TensorFlow Lite format. Then you have to just update it on the Firebase with the dashboard. Then you can use it inside your mobile apps. That easy. And I'm going to quick mention the TensorFlow Lite Convert, which is a tool available inside the TensorFlow Lite, which helps you to convert your model. I'm going to just show you how things works. For example, you can specify your inference type. At this time, you're going to obtain the model which is in TF Lite format instead of the protobirth. And in terms of dashboard, it's very simple. Just name your model and update. In terms of using it in your mobile application, it's actually not very hard. And the Firebase ML Kit team has been keep improving their documentations. I'm going to just show you how the steps are. So actually you have to define all the dimensions and the constants. These are actually the values you use in your retrain scripts. Then you have to set up a custom model classifier, which means define your local model source. Then define your cloud model source. Register your model source, so with both, and they can do the fallback correctly. Then you set up a model interpreter with an input dimension and output dimension. Then you have an input and output options. All the code are available on the ML Kit's website. And I just want to emphasize you have to always watch out the type of the data you use. Because if your model is stored as a float, you have to specify here. Otherwise, it's int. Then you have just to convert your bitmap to byte buffer. Then the byte buffer has to be normalized in a array. Then you can run the inference. Everything sounds really complicated, but actually it's just simple codes. At the end, what we obtain is actually the list of probabilities showing you which is which, and you can just do the mappings between the results and the list of your labels. Then you can say, oh, it's an apple, actually the first. And I did a quick comparison between ML Kit and the TensorFlow Lite. They're really similar in terms of performance. So at the end of last year, I was trying to build something new instead of just keep working on Magritte. So I built a hand robot. That is my small invention because when I was a child, I was always lonely. I was trying to play rock, paper, scissors with myself between two hands. I was like, this time I'm gonna build a machine learning, build a robot which has a machine learning inside it. It can recognize my gesture and play with me. So the idea behind the project was me playing with the robots, and the whole robots have like the same principle you just saw. So they have a machine learning model running inside its brain. The application was really just built with all the tools I know. There's a small app I use to send to my friends and the coworkers to collect a lot of images. As you know, in order to train the model, which recognizes the gesture, I need a lot of images. Then all my friends are sending me different kind of gestures, which is really nice. And in order to build the robot's arm, I used the servo motors. So servo motors actually can move the angle you needed in order to perform the movement. And in order to make 3 of 5, because I did the version of a rock, paper, scissors, laser, and Spock. So in order to manipulate several arms, I need to use one of the drivers, which is the 16-channel PWM Servo Driver. Also, I use Android Things, which is convenient because as an Android developer, you have almost nothing to learn. You can just get started. In order to glue them, I had some hot glue guns and I had some little operations at my place. At the end, I used the shoebox and I just attached everything together. So this is the final version, and I'll show you a video about how it works.
Press the button to start the game. 3, 2, 1, play. It's a tie.
So that's a tie, so the human is not winning at all. That version. It's another one playing.
Press the button to start the game. 3, 2, 1, play. I lost 3-1. Rock, brushes, scissors, and pace.
So as you can see, the Android Things, it actually just has so the camera is here, so it's his eyes. Every time the human plays, it just tells, oh, you win, oh, you lost. But since the precision is not very good and all the conditions is not very idle because the place you have influence of light and everything. So maybe next version I will try to add something feedback. So if my robot is messing around with the result or it's not getting it correctly, and the human can tell the robot, hey, actually I won and you lost. So it takes me a total a weekend to build it. Actually, very simple if you have all the knowledges. And I burned my finger several times, and my robot is very dangerous because it kind of just slap you on the face if you're not watch out. What I want to say is with all the tools we have today and with very little time to learn, and you can already build something really fun. Comparing to 10 years ago, building such kind of robots will require a lot of more knowledges in terms of machine learning and other artificial intelligence. And today it's just anyone can get started with it. So the takeaway for my talk today is I want to show you actually TensorFlow and MobileNet has already getting to a level which is really mature, and there's just new features keep coming, and TensorFlow Lite is now the standard solution for mobile and embedded related machine learning inferences. And there's a MobileNet v2 which is released last year, and it's currently in collaborations, and I think it will be soon available for all the application operations. Firebase ML Kit, it's still in beta, so API keeps changing. So every maybe 2 weeks, every 2 months when they release a new version, I find the package name changed, or the way to use API changed. But they're really taking feedbacks, so don't hesitate to maybe do a pull request, give them feedbacks. And currently, there's no callbacks for model downloading, so you don't know if your model downloading is successful or not, but it just fall back to your local model source. And more features are coming, as you can see, for natural language. You can recognize the text, which the language you're using, which is really awesome. And imagine one day your app, you don't have to ask people what's the language they're saying. You just give the app, and the app will recognize the language actually directly. And there's other trends in the whole machine learning for the mobile app domain. We talk a lot about mobile security, so how to actually secure your model, because currently when packaging your APKs, the model is not compressed. So anyone who has your application can just get your model. And for example, one of my friends was saying, if all the training data I use are really like sensible, how can I protect my models? So there's a lot of discussion still ongoing on this topic. And Google and other companies has been trying to develop more solutions which build the whole end-to-end artificial intelligence infrastructure. And we're talking a lot about pipelines, for example, how to build the whole feedback loop. So your model is constantly optimizing and constantly updating. We're talking about tools such as Kubeflow. Maybe some of you heard about it. And there's, in the research domain, there's something called Federate Learning. So Federate Learning is actually, you can update not the raw data, but only the incremental of the comparing to the existing model to the cloud. So that way, the privacy is better respected. But it's currently still in research phase, so it's not applicable yet. I was thinking about also maybe projects such as Google Translate for sign languages. Maybe with the power of our mobile devices, we can provide more functionalities, more features for disabled people. And with all the machine learning power and the hardware calculation power, a lot of disabled people can actually have a better life thanks to all the application, all the technologies. So technology for good, that's the central of, I think, our generation, and to do more social good to the society. So that's all. ありがとうございます. And you can find all the information here.